Hello guys. Today in this video we'll be discussing a medium difficulty question from LeetCode, that is reversing an integer. Now let's understand the problem statement and the constraints given to you. So the problem statement states that you have been given an signed 32-bit integer. Now by signed 32-bit it straight away says that it can be negative as well. So, and you have to reverse the digit. Now, if reversing causes the value to go outside the boundary of this signed 32-bit integer range, then we have to return 0. Definitely. Because if the value is outside 32-bit range, then we have nothing in hand because the input was signed 32-bit. Okay, we'll try to solve this problem with the time complexity of big O of n, where n is the number of digits in the number. Now let's first understand this with few examples and then proceed with the algorithm and the code. Now let's take an example. Let's say example we have 1, 2, 3, 4. What is the reverse of this number? It's straight away 4, 3, 2, 1. Now, if I have a negative 1, 2, 3, 4, what should be the reverse of this number? Minus 4, 3, 2, 1. And this is what is expected from us. Now, let's understand this with basic steps. So, we'll not consider the negative numbers for our primary case, and then we'll slowly move to considering the negative number. Now, why I want to skip negative numbers, I'll explain you when we are doing the positive number reversal algorithm, and then we'll understand why I don't want to consider a negative numbers on the first place. But we'll reverse the negative numbers as well, but for that we just have to add few checks while doing the number reversal logic. Now, let's take an example of a number, that is, let's say my x is given as 1, 2, 3, and 4. That's what I have x. Now, leave programming behind and just think of how you would do it in your mind. The first thing that you'll do is you'll first write 4, then you'll write 3, then you'll write 2, and then you'll write 1. So that's how you'll do in your brain as well to reverse any number. So this is my target, right? Now let's see how this target can be achieved programmatically. Now I just need you to know three mathematical operations for this program, that is a addition operation, a division operation, and a modulus operation. Now, why modulus operation? Modulus operation will help us to find remainders. Now, spelling might be wrong, but yes. So it helps us to find remainders. Addition and subtraction are obvious. Now, let's understand how we can do it programmatically. Now, let's take x. Let's take remainder variable and let's take a variable a. Now what a is, a would store the final value that we want to return, that is 4321. Now for x, right now I have 1, 2, 3 and 4. Remainder is nothing and a is nothing. Now tell me one thing, what is 123 modulus 10? What is the value? It would be 3. What is 120 modulus 10? It is certainly 0. So any number modulus 10 would always result the last digit of that number, right? So this is that we'll be using for our advantage now. Now, how we remove a digit from the last? Because once we write this 4, we need this digit 3, right? So we will want to remove 4 because that's of no use now for us. So if I want to discard this 4, what I do is I just divide this x by 10. So that would add a decimal over here in mathematical form, but in program, what it will do is it will remove this 4 because this decimal part would be removed. Now, tell me one more thing. Mathematically, let's say I have a number minus 1, 2, 3, and I modulus it by 10. So, what should be the answer? I am just strictly asking about mathematically. Let's leave any programming language for now. Should it be 3 or should it be 7? What it should be? It should be 7, right? So there are few programming languages which would return 7 and few programming languages which would return 3. So we want to write an algorithm that works across any language that it is run on, right? So that is why I am not writing the algorithm language specific. So we'll try to write an algorithm that works in all programming languages in any software language. Okay. Now, now, this is why I didn't want to practically consider negative cases for initial starters. And now we'll understand how to reverse the negative positive numbers, and then we'll move with the negative numbers as well. Now, let me take this remainder. So, if I find modulus 10 of my x, what would be my answer? It would be 10, right? It would be 4, sorry. So, I want to add this 4 because 4 is the first digit of my number, right? So, if I just do a into 10 plus 4, would that help me? Now why I want to do into 10, that we'll understand in the next iteration. That certainly would not be very clear in this iteration, but would be very clear in next iteration. So let me remove this part for now because this is of our no use. Okay. Okay. So a into 10 plus remainder. This is what I would write for each iteration in A's value. So A is 10, 10 into 0, A is 0, A into 10 is 0, 0 plus remainder is 4. Now X divided by 10 would give me 123. Now if I repeat this step, what would be my remainder? Now X is 123, so remainder is 3. Now you see A is 4. 4 into 10 is 40. 40 plus 3 is 43. And that's what I wanted. Now, to add a number to the right side of any given number, what you just need to do is you just need to multiply it by 10 and then add the number, because multiplying it by 10 gives you that last 0 digit, and to 0 you add anything, it would become the value that you are actually adding. So that's why I want to multiply it by 10, and because over here I am very sure that I would get just one digit number, that is by 10. If I am getting two digit numbers, then I would multiply by 100, but for us we are getting single digits because we are finding the remainder with modulus 10. That means we'll definitely get one digit number only. Now over here 123 by 10 is again 12. Remainder for 12 would be 2. 43 into 10 is 430. 430 plus 2 is 432. My x becomes 1. My remainder becomes, so 1 modulus 10 is always 1. So 432 into 10 is 4320, plus 1 is 4321, and my x becomes 0. Now, do you have to repeat this loop after this as well? No, right? So that means my loop should run till my x value is not equal to 0. That means my x is something greater than 0, because we are discussing about positive numbers. So we'll consider that x is greater than 0. Okay, so this is basic algorithm. Now let's understand this algorithm in words, and then we'll modify that algorithm to accommodate the negative numbers as well for us. So this is the algorithm that I've already written for us. So this algorithm is purely for positive numbers right now. So we have to run a loop where n is not equal to 0. Now by n, n or x, it's same for us for now, because n is somewhere something that some variable where the integer value has been supplied to us. Let's consider that. Now find r, that is remainder. Remainder, how would you find? The remainder is nothing but the last digit, but okay. So n modulus 10. Now a is a into 10 plus r, and n becomes n by 10. And you keep running this loop till n becomes 0 and come out and return a. So the positive number is converted to its reverse. Now, how would you do it for a negative number? Now, for this, over here, let's add a check over this place. Just before we start reversing, let's say the number that was given to us was x. And now I store my x in n variable. And I say if n is less than 0, multiply n by minus 1. So n into minus 1. So if n is negative, I make it positive. So if it is minus 123, I consider that to be 123. Then reverse it and add the sign in the end. That's it. That's simple, right? So that's how we'll do it. So we'll first convert this number to a positive number. If the number is negative, we'll convert that to a positive. We'll run this loop, and in the end, over here, step 2, what we'll do is we'll first check if the final value a is, now a will definitely be positive number because we are reversing a positive number right now, because n we have converted to a positive number, so we are sure that a is going to be a positive number. So if a is out of 2 to the power 31, if a is greater than 2 to the power 31, that means if my original number was negative, then it would be certainly less than 2 to the power minus 2 to the power 31 also. So if a is greater than 2 to the power 31, then we just have to return nothing but we have to return 0. Else what we'll do is, if my x was less than 0, my a should be a into minus 1. That means my x was less than 0. That means my x was less than negative value. Sorry. So if my x was negative value, my a should also be a negative value. Correct? Now I'll multiply a with minus 1, convert that to a negative number, and return a. That's my second step. So that's the only algorithm that's involved in this question. Now let's look at the code as well. So if you are liking the way I have explained the question, please do not forget to like, share and subscribe to our YouTube channel. And also press the bell icon so that you don't miss on any notifications for any new videos that we put across for you guys. Also comment down below if you want us to do any videos for you guys on any particular question from LeetCode, or any topic that is related to Golang or related to development or anything related to the software development languages. We would definitely be happy to help you guys out in that. Now this is the code that I have written for you guys in Golang. But if you understand the concept well of the algorithm that we just discussed, you can go ahead and try it out in any programming languages that you want it to be written in. So that's on you. But I've written this algorithm in, I've converted this algorithm to a code in Golang because that's a language of choice for me. But yeah, you're open to use any language that you want. Now let's first try and map each and every example, each and every step with this code. Now, in the first point, we mentioned that we would take that number x into an variable, that is a num or n. So I've taken that into a num. So this is my step 1. Step 1. Okay. Now this is my final. So a or final, same thing for me. So over here I've said that if x is less than 0, then I'll multiply the number with -1. So this is my point 2, to convert a negative number to a positive number. Now this is the algorithm for converting the positive, for reversing the positive number. So if you see, this is the point where I find the remainder. This is the point where I add that remainder to the final value, and I keep building the final value and also divide n by 10. So this is how I keep forming the reverse number of a positive number that has been given. Now, if my final value is out of range of 2 to the power 31. Now 2 to the power 31 means 1 left shift 31, because to find 2 to the power 31 would be a long task for us, and I don't want to do that, certainly, because 2 to the power 31 would be very big number and would be very hard to calculate easily, right? It's not a number that you would want to remember as well. So instead of remembering this, what I have used is a bitwise operator, and this takes a time complexity. So bitwise shifting takes time complexity of big O of 1. So it's even easier and faster to find any powers of 2. So that's why I've taken this into consideration for enhancing my speed of my program. So if the final value is greater than 2 to the power 31, I would mark my final as 0 and will move out of the loop. If my x is, let's say, if this final value was greater than or anything, let's say greater than 2 to the power 31, and also my x was less than 0, it was a negative value, then final into -1 would result me what? If final is 0, 0 into -1 would be 0. So that's why I don't care about that. That's why I didn't write that in an else if loop. So because that won't make any difference to us. Now if my x is less than 0, that means it is a negative value. Then my final also has to be a negative value, and final is the reverse of the number. So this is a place where I check that if x or the original number was less than 0, that is was negative, then I convert my final to a negative number and return final. That's it. So this is the program. And what is the time complexity of this program? If you see, so time complexity of this program is big O of n, where n is number of digits. And what is the space complexity? Because we didn't use any array or anything, just plain simple variables, so it is order of 1. So big O of 1. So space complexity is nothing but big O of 1. So this is the program that you'll be using to convert any number to its reverse. So that's it for this video today, and in case you liked the video and it was helpful for you, please do not forget to like, share and subscribe to our YouTube channel. Also comment down below in case you want any particular question from LeetCode or Geeks for Geeks to be solved by us on Golang, or any other topics that you want us to cover for you guys using Golang. So go ahead and comment down below as much as you want, any topic on Golang, using Golang. We appreciate you guys to do that.